Okay, I want to talk about the most interesting part of this chapter is the Polynesians and the art of navigation that they did way back, starting around 1500 BC. They used the stars as waymarks to find islands thousands of miles away in canoes. They were expert navigators. They would raise a young boy into a navigator all his life. They'd start him out about 8 years old, learning the stars. And there's about 150 stars that they would know by heart. They would know not only the time of day, the time of year the star would appear, but what other star would follow behind it. As that star moved west, another star would come right behind it, and which direction and what islands that star would go over. There was a remarkable sense of navigation for the Polynesians, and I'm going to play this little YouTube. One thing about this YouTube...
Imagine setting sail from home.
Stop it. One thing about this, the video is a little off on saying they use the moon and the planets as navigation marks. That's not necessarily true. The moon and the planets move too quick. So in that sense, this video is wrong. They use the stars mainly. And they had star charts as far as they didn't have paper, but they made star charts out of sticks, and they would bind these sticks together and make little patterns out of them and put shells for stars on these little wooden charts that they made with little palm branches or whatever, with a shell would be a star here and another shell a star there. So let's look at this, but I wouldn't I take this video with a grain of salt, but it's half decent, so we'll just go ahead.
Hawaii in a canoe. Your target is a small island thousands of kilometers away in the middle of the Pacific Ocean. That's a body of water that covers more than 160 million square kilometers, greater than all the land masses on Earth combined. For thousands of years, Polynesian navigators managed voyages like this without the help of modern navigational aids. Ancient Polynesians used the sun, moon, stars, planets, ocean currents, and clouds as guides.
Yes, clouds. Clouds would pop over the ocean, and you would see an island would create a cloud because the condensation rising from the heat of the land. Water vapor would rise up and make a cloud. So if you see a cloud off in the distance just by itself, you know that an island sits below it. That's one of their tricks. The sun is a star, so they did use the sun, but as far as, again, the moon and the planets, not so much.
That allowed them to see the ocean as a series of pathways rather than an obstacle. Their voyages began around 1500 BC, when the people who would settle Polynesia first set sail from Southeast Asia. Early Polynesians eventually settled a vast area of islands spread over 40 million square kilometers of the Pacific Ocean. Some historians believe the voyagers moved from place to place to avoid overpopulation, others that they were driven by war. Voyages became less frequent by around 1300 AD, as Polynesian societies became more rooted in specific locations. During the voyaging period, successful journeys depended on a number of factors: well-built canoes, the skill of navigators, and weather being some of the biggest. Voyages relied on sturdy va'akalua, or double-hulled canoes, which were powered by sails and steered with a single large oar. Canoe building involved the whole community, bringing together the navigators, canoe builders, priests, chanters, and hula dancers. Navigators were keen observers of the natural world. They were abundantly familiar with trade wind-generated ocean swells, which typically...
Now that's interesting. Yes, ocean swells act like radar. So they hit an island and bounce back, and all these waves would bounce back miles out to sea, and a good navigator could look at the ocean and see these wells, these waves coming back out, and know that an island was near, say within about 6-7 miles away, and because the waves that hit the island would bounce back out, and the navigator would look down and see it, and at night it would create like a bioluminescence. When the water's disturbed, all these little microorganisms would light up, and it'd almost be like a direct sign pointing to an island, because the light would come out in paths. Like streams of light would come out from the island, and the navigators would look at the streams of light and go, oh, wow, island is near. So they were pretty clever.
Typically flow northeast or southeast. By day, navigators could identify direction by the rocking motion of their canoes caused by these swells. But sunrise and sunset were even more useful. The sun's position indicated east and west and created low light on the ocean that made it possible to see swells directly. At night, navigators used something called a star compass, which wasn't a physical object, but rather a sort of mental map. They memorized the rising and setting points of stars and constellations at different times of the year. They used those to divide the sky into 4 quadrants, subdivided into 32 houses, with the canoe in the middle. So, for example, when they saw the star Pura Atea rising from the ocean, they knew that to be northeast. They had some other tricks, too. The Earth's axis points towards Hokupa'a, or the North Star, so called because it's the one fixed point in the sky as the Earth rotates, and always indicates north. However, it's not visible south of the equator, so navigators there could use a constellation called Neve, or the Southern Cross, and some mental tricks to estimate where south is. For instance, draw a line through these 2 stars, extend it 4.5 times, and draw another line from there to the horizon. That's south. But the sky also contains navigational aids much closer to Earth, the clouds. Besides being useful weather cues, under the right conditions, they can indicate land masses. For instance, the lagoons of Pacific atolls can actually be seen reflected on the underside of clouds.
That's true. You're out at sea, and you can see the underside of the clouds, and you can see a bluish, greenish tint on a single cloud, and that's reflecting of the shallow lagoons on the cloud surface. Pretty cool stuff.
You know what to look for. And high masses of clouds can indicate mountainous islands. Once navigators neared their destination, other clues such as the flight patterns of birds, floating debris or vegetation, and types of fish in the area helped determine the proximity of land. For example, the Manuoku had a known flight range of 190 kilometers and could be followed back to shore. So how do we know all of this? Partially through evidence in petroglyphs, written observations of European explorers, and Polynesian oral traditions, but also by trying them out for ourselves. In 2017, a voyaging canoe called Hokulea completed a worldwide voyage using only these techniques. If that seems remarkable, remember the ancient Polynesians, who through close study and kinship with nature were able to forge these paths across an unfathomably vast, vibrant, living ocean. The educator behind this lesson helped TED-Ed's...
That's a very good video. The only disagreement I have of it is the use of planets. Planets are notoriously bad for navigation. They only rise about 30 degrees off the horizon. They move fast. You can't trust them. And the moon's ridiculous. You don't use the moon for navigation. It's too quirky, and it just moves too fast. Stars are what you need. And outside of that, it's a pretty good video. So I'll just stop this and we'll go on to the next.